are equals even though it's already labeled.
What do you mean?
Because I remember you saying annotate, you wanted to show like this is the little n.
No,
Oh, you're just describing that.
You're just describing this. Yeah, you don't actually have to calculate it.
No, I know that, but do you really want us to like label what every number is?
No.
Or you could tell or write what you want. We should have this, what we should have is, right?
Right. You're just telling me that there's.
I think when you were talking through that, you were thinking on this, right, everything
Yeah.
like this.
No. I'm going into way more details than what you need to do. The annotations you make on your SPSS output can be done on this sheet. Okay, you don't have to write down everything I'm saying. But just understand and show me that you understand that it's providing some descriptive statistics. That's all you have to say. First, it's supplying some descriptive statistics, which has really, this is not the ANOVA yet. Here, you'll put an arrow saying this is where the assumption for homogeneity of variance was tested. Right? Maybe highlight this. Remember, this has to be greater than 0.05 for them to be the same. Are they the same? Yeah. Yeah. So do we meet the assumption? Okay, so we can put therefore the assumption is met. Just explain that right over here. The Levine's test.
So this is where the assumption for
Homogeneity.
testing,
Yeah.
that makes sense.
And according to the Levine's test, it was significant. Okay. P was greater than 0.05, meaning that the variances were equal. Therefore, the assumption was met.
That allows you to go on to do the ANOVA.
Right. You have to meet those three assumptions that we talked about. This was one that SPSS rejected. Now we come to the ANOVA table. Remember that ANOVA table we wrote on the board last week? Here's the ANOVA table right here in SPSS. So here are all the sum of squares that we got by hand. Here's all the degrees of freedom we got by hand. The mean squares for between groups and within groups. Remember I made that mistake and did the total. We're not doing the total, it's not supposed to add up. The F statistic, which is this, divided by this. And then the p-value, which is 0.00. Basically, it's less than 0.0001, which is less than 0.05, meaning they're different or the same. They're different. Remember, if it's greater than, we're saying we fail to reject them. So here we're saying they're different, okay, which is what we found here as well. 86.33 is much greater than the 3.55 in the book. Is everybody clear on this table? This is just the ANOVA table that we made last week. And we can make again with all our calculations.
So if there's 0.00 as a significance, it's a very small significance.
No, it's much smaller than 0.05. But anything under 0.05 would be statistically significant, meaning there's a difference in means. We don't know which ones though yet, or which pair. So this is now the end of the omnibus test. Okay. You just explain that right here in the margins, that would be fine. Julie?
So, any composer specifically so we can go on and do that. Is that what you're saying?
No, that was the ANOVA.
Oh, okay, tell me about, okay, because T is greater than 0.05.
For the Levine, which part are you talking about? assumption? Remember, the assumption is stating that the variances are equal. So the null hypothesis is saying that three variances are equal. Right? We have to meet this assumption before we can do the ANOVA. The alternate hypothesis is stating that the variance of one of these is not equal to the variance of another. So because the p-value, 0.877 is greater than 0.05, we fail to reject the null hypothesis, meaning we've met the assumption. You're welcome. Right. Yeah, they're not the same. We want the p-value less than alpha to reject the null. If it's greater than alpha, we fail to reject it. Now we go on to the post hoc. Okay. Look right here. We have all the differences. The difference between 0 and 50, 1.429, which is the same as what we got. The difference between 0 and 100, 5.14, yep. What about 50 and 100? 3.71. Yeah. So this is basically that table right there. What can we say here? Look, it puts a asterisk where there's a statistically significant difference. There's a statistically significant difference between all three pairs. Is that clear to everyone? Just highlight this. This is where you're getting your information. I just need to know where you're, if you make a statement, I need to know where on the SPSS output you got that information to make that statement. Okay, so all you do is highlight this and say, this shows that there's a statistically significant difference between all pairs of means. Up here, I would highlight this number, okay, because that's the number you're looking for, to say that it was statistically significant. Okay. This number has to be greater than FCB. This is the p-value, it's less than the alpha level, which is type 1 here. Now it gives you some extra information. You don't really need this. Okay, this is just showing you the means here that we've calculated. This right here is a plot of the means. So which condition resulted in the highest level of anxiety? 0. So see how the graph was useful? I'm able to see just real quickly. Okay, 0 had the highest level of anxiety. What had the second highest? 50. So did 50 have an effect? Yes, it was a statistically significant difference. So if you took 50 milligrams of the medication, say, it did have a marked difference in anxiety level in the patient. What about with 100? Yes, even more. Okay. Look how low it got. You can say which one had the greatest effect. You could say that, or condition 1, condition 2, however you want to do it. I mean, I'm not, like I said, I can't stress this enough because I see everybody writing down together concerns about exactly how to word it. If I can tell that you know what you're talking about, if you understand the SPSS output, it's going to be readily apparent to me. Okay? And if you don't understand it, I'm gonna be able to see. Okay? All right, any questions on this? Okay, so this is how you do the one-way ANOVA using SPSS. And it did the omnibus test and the post-op.